There are 3 different types of equations that we can create while using these log and exponential word problems. Now, the first is when you're compounding interest. The second is where you have half-life. And the third is where you're compounding interest continuously. Now, which one of these do we think involves E? Which one did I say involves E? Which type? Compounding, interest, half-life, or compounding continuously?
Continue.
We learned that we use E most of the time in the real world when we're being asked to compound continuously. So that last type of word problem is where we're going to be using E. The first one, however, is just compounding interest. So this means at any other rate besides continuous. So yearly, quarterly, biannually, monthly, all of these were compounding interest, just at different time intervals. So when we're being asked to compound interest, this is the formula you are going to use. And you can pick any variables here, really. It doesn't matter. They're just variables. They're placeholders, right? So I'll do A of t is equal to A sub 0. What do you think A sub 0 stands for? Initial. Now, because we're compounding interest, this is the initial amount of money. A sub 0 is your starting, the amount that you're depositing, you're investing. And then it's times. Now, we're not using E, so what do you think we have to do with the rate? What did we do before, last unit, when we didn't have E with the rates? What did we do with the rates? We had to add what to it? Same thing here, because we're not continuously compounding. We have to add 1 to the rate. So 1 plus our rate. Now, because it may not be yearly, right? It might be biannually or quarterly or monthly. We can't just put R here. We have to put R over N, where N represents the number of times a year you're compounding the interest.
So, if it was biannually.
Yeah, how many times is biannually?
That's once.
Twice, 2 times a year. Biannually means it happens twice a year. Oh wait, biannually. Oh, that's every 2 years.
Yeah, that's.
Oh,
It'd be like 0.2.
so it'd be 0.5.
Oh, I guess that would be.
1/2, right?
Yeah.
So what is yearly? I mean, 2 times a year. What is that called? They don't say like quarterly. They have quarterly.
I mean, you can say.
Interesting. Huh. Strange. All right. So R, and then of course is our rates, and all of this is raised to the power of R times T. N times T, where T is our number of years. All right, so let's try it. When Kyle was born, his grandparents invested $5,000 in a college fund that paid 4% per year, compounded yearly. So, if we're compounding yearly, what is our N? 1. So, do we even really need an N in this first part? No, because R over 1 is just going to be R. and then t times 1 is just going to be t. So there is no n. It's just 1. So it says, what was the value of the investment when Kyle was ready for college at age 18? So at age 18, how many years have passed? 18. So what variable are we replacing? T. So t is 18 is equal to, what's our initial amount? 5,000. And then, do we have an n? No, right, it's 1. So we can just do 1 plus the rate. What is the rate? Yes. So our rate is 0.04. We add 1 to it. What we're putting in the parentheses now is 1.04 raised to t, which is 18. So then how can I solve for my amount, my new amount? Do I have to log roll here?
No.
Why do I not log roll?
You have all the information.
Oh, right? I know what my t is. I know what my rate is. I know my initial amount. All I have to do to get my new amount is plug this in the calculator. So what do I get?
Semi-annually.
Semi-annually. Thank you. Semi-annually. Huh.
No, I was looking it up too.
Ah. Don't all rush to your calculators. No, no, no.
10,129.
What is it?
10,129.
Beautiful. Point.
0.08.
Oh, wait. It is a dollar amount, so you do have to put to the hundredths place here. So in 18 years, his amount basically doubled. It's pretty good. What would be the value of the investment if it was compounded quarterly? So what has changed?
The N.
Ah, we now have an N. What is our N if it's quarterly?
4.
4 times a year. So our N is 4. So now we're still doing when he's 18 years old, but now I'm introducing an N. So it's 5,000, then it's 1 plus 0.04 over our N is 4. And then our N again is 4 times the years, which is 18. So somebody tell me what that amount is. Not quite.
There's another word, biennial, which is biennial.
No, it's different.
B-I-E-N-N-I-A-L, and that means it reoccurs every 2 years. That's that one.
So it's the same as biannually. Biennial.
Google says that
Like a centennial is, 100 years.
Centennials,
Google says that it's like people interchange them a lot.
Oh, I
They're
see.
not really
I see.
supposed to be, I guess.
Okay. So when we plug this side in, what do we get? Biannually. You guys are so full of life.
You're full of life.
Literally.
Literally.
That's a
Beautiful. Point what? 49?
It's 50. It runs up.
Oh, okay. So, looking at this, which is better? Which one does he get more money with? Quarterly. So we want it compounded quarterly. Now this is exactly why when you guys graduate college, if you have student loans, the banks compound your interest continuously because they get more money. It's great.
Love that.
Yeah. They get more money, so they're like, oh yeah, it's a continuously compounded. No, you don't get to choose. Nope.
Do you get to choose on other things?
Whenever you take out a loan, no. Whenever you take out a loan, it's always going to be compounded continuously, no matter what it's for, because they want more money. Unless you take out a loan for your parents, then it's like, okay.
Does that make it harder to pay off?
Yes. For example, I graduated college with only $31,000 in loans, and if I had just done the bare minimum amount, in 30 years, I would have paid $125,000 for $31,000 borrowed. So that's why you never, when you graduate, don't make this mistake, don't pay the just bare minimum, because then you're only paying the interest. And you're just barely, you're not paying on the principal at all, barely. So they're going to just keep adding on, keep adding on, keep adding on. So you want to pay more. You want to pay more than is barely required, because otherwise you're going to pay a crazy amount in the end. All right. So, half-life now. You guys, I believe, or you are going to be learning about half-life in chemistry, I think. You might have touched on it a little in 8th grade, but you are going to be doing it in chemistry. So, when we have a half-life problem, what does that mean? What is a half-life? Yes.
Like how long it takes for half of the original.
Yes. How long it takes for something to, are we growing or decaying with half-life? Decaying. It's how long it takes for something to die halfway. So, our equation for half-life is, we'll do A of T again, is equal to the initial amount times 1/2, that's why it's called a half-life, raised to the power of T, our time, over lambda. Lambda kind of looks like a curvy upside down Y. Lambda kind of looks like a curvy upside down Y.
Okay, so it's 1/2.
So T is our time. A sub 0 is our initial amount. And lambda is the time it takes to decay in half.
Yeah.
So here this problem says the half-life of a thorium-234 isotope, a type of thorium, is 25 days. If you start with a 70-gram sample of thorium-234, write the equation. So, what is our equation going to look like for this situation? A of T is equal to 70 grams, that's our initial amount, times 1/2 raised to,
25.
do we know the T? Do we know the time yet?
T over 25.
T over 25. Now I had a good question last period. Is half-life always measured in days? No, for sure not. It could be measured in seconds, minutes, years. However, the only stipulation is if your half-life is measured in days, your time needs to be in days as well. So if it says, oh, how much will be remaining in 10 years, you can't just put a 10 here. You'd have to figure out how many days that is. Does that make sense? All right. So, how much will remain after 100 days? What are we doing here? For T, we're putting 100, right? So A of 100 is equal to 70 times 1/2 raised to 100 over 25. Excuse me. Do we have to log roll here?
No.
Nope. No, we do not. What do I do? Just plug it in, right? We want to know what a of 100 equals, so plug in this right-hand side. 70 times 1/2 raised to 100 over 25.
4.37.
4.37. And what is our unit?
Grams, days.
Grams.
So that's how many are left.
That's how much is left. And this makes sense, right? Because this means every 25 days, the sample is cut in half. So after 25 days, our sample size goes down to 35. Then after another 25 days, it goes down to half of 35, 17.5. Then after another 25 days, it gets cut in half again and again. So now it asks, what is it going to be after 1 year? So what are we doing this time?
Your t-value is 365.
Our t-value is what?
365.
Yes, because we need to keep it in days because our half-life was in days.
Is every equation in days? Or
No.
it just depends on how it starts?
Right, it depends on how it starts. Very good. Oh, I was about to put equals, cheapers. 365 over 25. So after 365 days, how much of our thorium is left?
0.0002.
Very good. So notice this is getting closer and closer and closer to what?
0.
0, because 0 is our what here? It's our asymptote, right? If we keep cutting something in half, cutting something in half, cutting something in half, can we ever cut to 0?
No.
No. It just keeps on getting closer and closer and closer to 0, but never actually touching it. It has an asymptote at 0. And then it says, when will there be less than 1 gram left?
At 365.
No. Yes, what do you need to plug in?
Y.
Ah, for the y value, right? The a I keep saying sub. A of t, we need to plug in 1. We want to know when there will only be 1 gram left, right? So we're going to plug in 1 for the left-hand side. And we need to figure out what time this happens. So, how do I get a variable out of an exponent? You log roll. Can I immediately log roll here? No, why not? Because of the 70. Your exponential term is not by itself. So what do I do first? Divide by 70. So I divide by 70. So I have 1 over 70 is equal to 1/2 raised to the power of t over 25. Now what do I do? Yes, now my exponential term is by itself, so I go ahead and log roll. I start with my base, which is 1/2, and I roll towards the equal sign and around. So I'm log rolling, I'm converting this into a what? A log. So what do I need to write? Log base what? Of equals. Is my t by itself yet?
No.
What's my last and final step here? Multiply by? So I have 25 times log base 1/2 of 1/70. What is it? Point 3? 2.3. Now, it says, when will there be less than 1 gram left? Am I going to put an equal sign here?
It could be less than.
Ah. Now, here is where the thinking comes in, right? Do I want t to be more than or less than this value?
More days.
Right. If you're thinking about this on a graph, we know that this is a growth or decay half-life. Decay. So at this point, I'll just say, at this point, 153.23 is our time. At that point is where it becomes less than 1. We don't want all the values less than 153, right? We want everything greater than 153. Will give us a value less than 1. So we need the time to be greater than 153.23. Right? All of this is less than 1. So we need bigger than 153.23. Oh. Yes. 153.23. I know this is very small paper. I'm so sorry.
It's days, right?
Days. Good. Thank you.
Just thin.
What?
Just thin.
It's just thin paper. Oh, skinny. All right. So now to the easiest one, actually. Compounded continuously. What did I say we use when we're compounding continuously? What do we use? E, right. So actually, we've done problems like this already. We've done compounding continuously already. Does anyone know how this is going to be set up? This equation.
It has like LA in it.
No, it has E in it. Remember, this is interest, right? Compounded continuously interest with interest. So we hope that if we're depositing, if we're depositing, we're increasing. So it's a growth. So we wouldn't use ln because ln that's not going to be the correct graph. It is an exponential graph. So what did we say is going to be in it? E. What do you think I multiply E by? Oh, our brains are like on pause right now. Come on.
Brain break.
No. Okay, Eric's thinking the initial amount. We're going to multiply E by the initial amount, right? Just like we did before in the regular compounded problem. So this is initial amount. And it's equal to A of T. Now, is it just going to be this? Am I just going to multiply my initial amount times E, which is 2.718? No. What do you think I need in this? I need the time. What else do I need? The rate. So how am I going to put those in this equation?
It's the exponent.
It's the exponent. R times T is our exponent. I know that we've done a problem like this. Can't remember what day because my memory is really bad, but we've done this. So, Bam Bam makes a $500 deposit to start a savings account. The account pays 1.85% interest compounded continuously. Then we're asked to find the balance in 1 year. So what variable are we replacing here? The t. The t is 1. So we're asked to find the amount when the year is 1. Our initial amount is how much? 500 times e raised to the rate, which is what? Now remember, this is compounded continuously. We do not need to add 1. 0.085 times the time, which is 1.
No, 0.018. Yeah.
What?
0.018.
Oh, thank you. Yes. times 1. So we plug that in our calculator, and how much has she earned after 1 year?
Oh, wait. Oh, the balance? Okay, yeah, balance. 509.33.
Beautiful.
So wait, if it asks us for how much she earned in 1 year, we would have to subtract 500 from that.
Yes. And then it says, what is the balance in 10 years? So now we're replacing t with 10. The rate stays the same, 0.0185 times 10. And what do we get this time?
601.
0.61. Any questions on any of these 3 types of problems we've done today? Basically, the hardest part about them is remembering the formulas.
We'll have to memorize
Oh my, how it goes. All right.